Technology has advanced in leaps and bounds this year. From robots running like humans to commercializing nuclear fusion, engineers keep pushing the limits of what we know is possible. Here are the top engineering news stories of 2025. Earlier this year, MIT made a breakthrough in the realm of quantum computing. They've developed two new control techniques that have enabled them to achieve a record-breaking single-qubit fidelity of 99.998%. How? Through the use of a superconducting qubit called fluxonium. Fluxonium qubits are known for their high coherence and noise resistance. It just so happens that qubits, the building blocks of quantum computers, are highly susceptible to noise and control imperfections. So by applying commensurate pulses at specific times, the researchers are able to make counter-rotating errors consistent and correctable. Synthetic circularly polarized microwaves are also used to control the qubit state, further enhancing fidelity. This development will be instrumental in pushing quantum computing performance even higher. Humanity isn't just trying to break records within the quantum computing space. Over in the astronomy sector, more and more scientists are trying to engineer ways for humanity to survive long-term space travel. The goal? To send the first human being to Mars. One of the avenues being researched is faster space travel. After all, humanity won't have to survive prolonged periods of time in a spacecraft if most of that time can be shaved off. This is where the Russians come in. Rosatom scientists have announced the development of a plasma-electric rocket engine that they claim could send spacecraft to Mars in just 1 to 2 months. As reported by Russia's Izvestia newspaper, unlike traditional rocket engines that rely on fuel combustion, this innovative propulsion system utilizes a magnetic plasma accelerator and promises to reduce interplanetary travel time significantly. Under this approach, hydrogen is used as fuel and the engine accelerates charged particles, electrons and protons, to a speed of 100 kilometers per second. With a calculated thrust of approximately 6 newtons, the highest among comparable projects, the engine is expected to enable smooth acceleration and deceleration phases during interplanetary travel. A faster journey to Mars would not only increase efficiency, but also minimize the risks associated with prolonged exposure to cosmic radiation for astronauts. A laboratory prototype of the engine has already been developed at Rosatom's Troitsk Institute. This prototype will be subjected to extensive ground testing to refine its operational modes and pave the way for the creation of a flight model, expected to be ready by 2030. Even as Russia's spaceship takes flight, other innovations in aircraft and energy are taking to the skies. China takes front and center with its brand new contribution to the world of renewable energy. This year, they successfully completed the first flight of its home-designed floating wind turbine, the S1500, in Hami, Xinjiang. The S1500 is a megawatt-scale commercial system that floats in the sky like a giant zeppelin. Measuring approximately 60 meters long, 40 meters wide, and 40 meters tall, it is by far the largest airborne wind power generator ever built. Unlike traditional turbines, the S1500 does not need a tower or deep foundation. This reduces material use by 40% and cuts electricity costs by 30%. Additionally, it isn't fixed to the ground. The entire unit can be moved within hours, making it suitable for deserts, islands, and mining sites. How does it generate power? Its main airfoil and annular wing form a giant duct. Inside this duct are 12 turbine generator sets, each rated at 100 kilowatts. These rotors capture steady high-altitude winds and convert them into electricity. Finally, a tether cable transmits the electricity to the ground. High-altitude turbines could become a crucial development in harvesting wind energy. Winds between 500 and 10,000 meters above the ground are stronger and steadier than surface winds. When wind speed doubles, the energy it carries increases 8-fold. Tripling the speed creates 27 times the energy. If we can construct more high-altitude turbines like S1500, we can generate much more power than conventional land-based wind energy systems. And with perfect timing too. As the world grows more and more dependent on AI, the more resources are being poured into it. This includes chips. GPUs are crucial in providing the processing power needed to handle all the data an AI model goes through day by day. so now everyone is scrambling to grab them. This year, the biggest headlines about AI were on Trump's tariff war with China. Out of all the goods he placed a tariff on, valuable computer chips were at the top. Trump barred the sale of NVIDIA's H20 AI accelerators to China and other relevant countries, trying to put them on the back end of AI development while the US raced ahead. It put the GPU company in a tough spot, forcing them to choose between their two biggest customers. For months, the tariff negotiations went back and forth, not just between the US and China, but between the biggest GPU companies in the US and their government as well. In the end, NVIDIA and AMD agreed to pay the US government 15% of their revenues from semiconductor sales to China. In exchange, the US would provide them licenses to export their products there. Now, there's nothing holding back both countries from pouring everything they have into developing their AI data centers. What about energy? How do we answer the energy requirements needed to power these massive data centers? Most people have turned their gaze towards nuclear power. If we can master nuclear fusion, we could create powerful, long-lasting, and most importantly, renewable sources of energy for the entire world. This is where UK-based Tokamak Energy comes in. Creating fusion energy requires extremely strong magnetic fields. As hydrogen fuel is heated to a plasma state several times hotter than the sun's core, it's kept safely contained by those magnetic fields. Tokamak Energy just made a significant breakthrough in the development of clean energy by successfully replicating fusion power plant fields within its Demo 4 magnet system. In a functioning fusion power plant, superconducting tapes must operate within a complex magnetic environment created by neighboring coils. These conditions significantly influence structural performance and critical current. Demo 4 allows engineers to generate and study these fusion-relevant forces across a system coil set, which includes 14 toroidal field magnets and 2 colloidal field magnets. During recent tests conducted at the company's headquarters near Oxford, the Demo 4 system achieved magnetic field strengths of 11.8 Tesla at a temperature of -243 degrees Celsius. This is the first time in the world that such fields have been created in a full high-temperature superconducting HTS magnet configuration. The tests also highlighted the commercial potential of HTS technology for sectors outside of fusion energy. HTS materials can deliver approximately 200 times the current density of copper, making them viable for power distribution in data centers, electric motors for zero-emission flight, and magnetic levitation transport systems. According to the company, these magnets can be made smaller and lighter than traditional low-temperature superconductors and operate at a fraction of the cooling cost. With this research, engineers can further scale nuclear fusion technology for future energy-producing systems. Even as we develop more sources of energy, we also develop new ways to store it. This time, our story takes place in Korea. A joint research team from KAIST and LG Energy Solution have managed to address the long-standing dendrite problem in lithium metal batteries. They've developed a new lithium metal battery technology capable of powering an electric vehicle for 800 kilometers on a single charge. Even better, they're capable of recharging in just 12 minutes. This enhanced range would substantially reduce range anxiety for drivers and open up new possibilities for long-distance electric travel. The breakthrough also enables a battery lifespan of over 300,000 kilometers. This effectively solves a critical safety and performance issue that has long hindered the advancement of next-generation EV batteries. How is it possible? It's all thanks to the creation of a cohesion-inhibiting new liquid electrolyte designed for lithium metal batteries. Lithium metal batteries replace the graphite anode, a key component of lithium-ion batteries, with lithium metal. The research team developed a new electrolyte which utilizes an anion structure with a weak binding affinity to lithium ions. This ensures lithium is deposited smoothly across the anode, effectively suppressing dendrite growth even under rapid charging conditions. The technology overcomes the key trade-off between energy density and charging speed that limited previous lithium metal battery designs. It enables stable operation and a long driving range without sacrificing the convenience of a quick recharge. This lithium metal battery innovation could bring forth the next generation of not just batteries, but electric vehicles as well. Of course, there's one last industry where we've seen the greatest, if not the most impressive innovations this year: robotics. And there's no robot that's been hyped up as much as the Tesla Optimus. The Tesla Optimus stands tall at 5 feet 11 inches and weighs 160 pounds, featuring over 40 degrees of freedom, including highly dexterous 11 DOF hands designed for human-like interaction. It runs on a 2.3 kilowatt-hour battery, enabling nearly all-day operation, with exceptional energy efficiency ranging from just 100 watts at rest to 500 watts while walking. This split-screen video shows just how far the robot has come. From a slow, awkward gait, it's now capable of running at a steady and balanced jog. By mid-2025, Tesla demonstrated that Optimus was performing increasingly complex tasks, including walking, lifting small objects, and executing scripted tasks such as pick-and-place operations and basic assembly work. Its first demo, titled 2.5 Gen Optimus, was still sluggish when asked to do a simple task. In October, the robot showed significant improvements in performing kung fu moves alongside a trained professional. Though still under active development, Optimus is expected to enter mass production soon, according to Tesla. Modern factories already rely heavily on industrial robots, and humanoids represent the next step: machines that can perform the tasks current robots can't. And that's all for 2025. With such amazing developments, what could science bring next year?